Good morning, guys.
Morning, sir.
Very good morning, one and all. Any doubts so far? Have you practiced the sessions which you have discussed, or anything you want to ask?
Yes, sir.
Okay, what about the rest? Guys, is it clear? Everyone?
Sir, I
Yes?
have one. How we set the number of parts to be entered?
Okay. Can you show your model? Can you share your screen? So that I will explain
Yes,
you
sir.
in your screen itself. Okay.
Yes, sir.
Now, what you want? You want to give the number?
Sir,
Hmm.
yes, sir. Number of parts to be entered in the source.
Okay. Enter, double click.
Yes, sir.
So, what exactly in the second option? Time of creation.
Yes, sir.
In
Time of
that
creation.
drop down menu, click it.
Number adjustable,
Yes, number
right?
adjustable, and you
Yes,
need
sir.
to define the parts. Define it. How many parts you want?
Amount,
Yes,
right?
right.
And
Then,
then okay.
okay.
Done.
Open the event controller, reset it. Reset.
Right.
Always reset the simulation. Yes, and run it.
Yes, sir. Reset.
Increase the speed.
Yes, sir.
Check the process. 10 parts were completed, and the source is not producing any part.
Yes, sir. Yes.
Okay.
Yes, sir. Okay, sir.
Okay. What about the rest?
So
Yes.
yesterday I asked about the like my simulation is not running. I said so.
Okay. Now, can you share your screen or you have logged in your mobile with your mobile?
No, sir. Yes, I will share my screen. Sir.
Okay, share it.
So is it visible, sir?
Yes, you have given 10 seconds of time.
Yes, sir.
Just remove that one. Just remove the time once. Okay, apply. Okay, and okay, double click it directly. No need of that many options. Just double click it. You will be getting that pop up.
Oh, sorry, sir.
Reset the simulation. Reset it. Click on real time. Enable the real time. Enable the real time. Okay, it's running.
Sorry, sir. Thank you, sir.
Okay, thank you.
एक्सक्यूज मी सर।
Yes.
सर इस प्रोसेस में सर जो ये स्टार्टिंग वाला जो कन्वेयर है उसमें इतना स्टोरेज क्यों होता है?
जैसे मैंने ऑलरेडी आई हैव एक्सप्लेन यू दिस वन. फिर नो प्रॉब्लम. आई विल एक्सप्लेन यू अगेन. The conveyor is connected with the input, I mean source, which means source is continuously producing the parts. Okay, if my source is having 100 parts, the source is completely giving the parts to the conveyor. That is why the source, after the source, if there is a conveyor, the conveyor is always in a blocked phase. It will be directly connected to the machine, and the machine is having some processing time. Based upon the processing time, the part will going to pick from the source. So there is no problem. I mean, before the first mission, if there is a blockage, that is not an issue. That is a generalized representation. Okay, why? Because just observe it. I'm having a thousand raw material with me. All the raw material will be stored at a place. Now I want to run the procedure. Here what will be happen? One part will be collected for a operate for procedure, right? So from 1000 I am collecting one part, and there will be having 999 parts. I am having using second part, still it will be having 998 parts. So anyhow the I mean at the input, at the raw material, at the store or the source, will be having a lot of blockage. That doesn't impact the process actually. So we are going to consider the process from the station 1, not before the station 1. Okay,
Okay, sir.
what about the rest? Is it clear so far, everyone?
Yes, sir.
uh, just a second, let me call by name someone. Mr. Jaivir Yadav. Mr. Jaivir Yadav. Mr. Chirag. Mr. Chirag. Fine, when I call your name, if you don't respond, it's up to you. Okay? I'm not forcing you, I'm not doing anything. Next, Mr. Deepak.
Yes, sir.
Can you share your screen?
Yes, sir. Yes, sir.
Okay, so what have you done? Input C1, S1, and there is a turntable, angular converter. Fine. Can you run the simulation?
Yes, sir.
Okay, run it. Fine. Okay. Clear so far? Thank you. Next, Mr. Srishant. Mr. Srishant. Miss Paridhi.
Yes, sir.
Can you share your screen? Can you show your model?
Sir, sorry, sir. Right now I'm outside, sir.
Fine. You have stopped sharing it. Can you share it again? Yes. Okay. Can you run it? Can you run the simulation? From where this turntable is collecting parts? See, there is input for the turntable. Can you please a bit louder?
So this is the source, this one.
Okay, from this source the turntable is collecting parts.
So this one on the other side, I just shifted it to C.
Okay, fine, not an issue. Fine, thanks for sharing. So I hope it's clear for everyone, right?
Yes,
Yes.
sir.
Okay, if you are having any doubt, you can call, you can ask me. Fine, let's start the session. So before starting it, let me close this model and open model file. What is the model which we have worked? 10, I hope model 3. Okay, so this is what we have practiced yesterday. So clear with all the material handling devices, right?
Yes, sir.
Okay, now save as model file. I am saving the file initially. Now fine. Save. Okay, now I am going to use a robot. Okay, here today I will explain you multi-station, robot, store, buffer, all these things. Okay, for that, so input and an output, it is common. Here I am
Sir, I think your screen is not presenting, sir.
not presenting. Just a second. Resume. What about now?
Now it's fine, sir.
Okay, fine, thank you. See, I am using an input and an output, and here I am using a station and another station and one more station. Okay, I hope they were aligned horizontally. I want to distribute horizontally. Fine. Now, if at all I want, I can rename it. As of now, I don't want it. That is why I'm not renaming it. I will be using them as a default one only. Here, I will be changing its position. Now, how to do this material handling from station to station 1? What are the different methods for doing a material handling? Initially, we have used a connector, which means what exactly a connector will do.
Just show representation for material handling,
Okay,
material movement.
yes, it is a representation for material movement. Now, in real, if I want material handling, then what is the thing I need to use here? I,
Conveyor.
yes, I don't want this one, I'm deleting. I don't want this one, deleting. Okay, same. I will be using this. Either we can use conveyor, this is what exactly conveyor will be, so that the material we are handling will be performing. Okay, now see, fine. I don't want drain here. There are two missions and two conveyors and another conveyor. Control C, Control V, and Control C, Control V. Fine.
सर,
Yes.
जब आप कॉपी पेस्ट करते हैं तब ये जो स्टेशंस के या कन्वेयर के जो नाम है इनमें जो नंबर्स आ रहे हैं इनमें कोई पैटर्न है क्या?
Yes. See, this is the reference. Convey 21 is the initial number. Now, if I copy and paste, what will be happen? 21 will be the parent, and the next number will be the subordinate number. That is why 211. If I copy paste this one, it is a main name is parent name is control 2. If I paste it, control 21. See, I am clicking this copy and pasting it. 2 3, 2 4, 2 5. So it follow an order. First number will be the parent number. After that, the subsequent numbers. Here 2 1, 2 2, 2 3, 2 4. Like that, it will follow an order. Okay.
Okay, sir.
Yeah. Now, see, this is what exactly my station will be. Line will be. This is a production line. Here, what is happening from this source? The material is coming till this section, and the material need to enter from this station to this station. I can directly connect it by using a direct conveyor, or else I will be using a robot here. See, I am placing a robot and placing here. Okay, this is what exactly a robot will be. So I can place in between these two cells. In plant simulation, for any component, if at all I want to use any component, there are two mandatory things. One is input and one is output. Similarly, for this robot also, if I place a robot, then what is the important thing? That is input. So input is coming from conveyor 2. Okay, now I want to connect this vision with this robot, I mean this conveyor with this one, then only the material will going to enter into robot. So for that I am clicking this connector, connecting the conveyor. What happened? Open last model. File was trashed. Okay, fine. Input, I'll be using 1 2 3 4 and a drain. Now I want to use connector, this one, and here from this station conveyor, and from somewhere to conveyor, and a connector. One more thing guys, whenever you have done a model, so once this lane was created, then try to save it, otherwise you will be facing the difficulties which I have faced right now. Sometimes what will be happen, x of tools or overcoming the tools, it will the file will going to collapse, the complete transformation will be closed instantly. Sometimes it will going to happen. If that will going to happen, what will be happen, the program which you have created, the model which you have created won't be saved, everything will be lost. So again, you need to start doing from the initial things. That is why whenever you have done a model, try to save it regularly, so that even though it was collapsed, the previous saved model, you can use the previous saved model as a reference. Now here I am placing a robot. Input I have given. Now input was done. Now what is the next thing I need to do? What is the next thing? I need to
Need
output also from this to this one. See, now the robot is connected with input as well as output. If I run the simulation, let me open this one, double click it, reset the simulation and run it. Part will be entering. Let me increase the speed. See what is happening, the robot is picking part from this but not from the conveyor. Why? The robot is picking the part from air, at here only, at this region. If you observe it, see, it will going to give the material at this position only. If at all I want the robot to collect material from the conveyor itself, and I want to deliver the part to the conveyor itself, then I need to observe the robot envelope, that is called as a working area of robot. Here, see, the maximum reach is this much, so I need to place my conveyor here. Same with this also. Now, just have a look. Clear? This is how we need to place a robot. So it should be in the robot reach. Otherwise, what will be happen? The robot will pick and place the material, but it is not in real when we see it. Now I am placing like this. Now have a look. It will be clear. When the part comes, robot will reach to this position. It will pick automatically and it will deliver to this conveyor. Clear? See, this is what exactly a simple robotic application is, which means if there is a conveyor and I want to pick a material, then I need to connect with the conveyor and robot. And once the input was done, then the robot need to deliver the part to some other station. So I need to connect this robot with another conveyor. So it will be collected the parts from conveyor 2 and it will be delivering to conveyor 3. This is what going to happen in a line. So we'll call this as also material handling application. This is first application. Now there is one more case. Second case is I'm having another conveyor. Same, I'm having one more machine with it. Okay, and a drain. So which means this robot need to collect the material from this station. It need to deliver to both the conveyors. For this, what I need to do?
We will connect the robot with the second conveyor.
Yes, the robot with second. Now a connection was raised. Reset it, run it. There is no need of slow. I'm increasing the speed. So observe it. First part will be delivered and second part will be delivered. First to that and second will be like this. This is how the material handling will be given in the lines. Clear? The same thing. If there is another input,
Isn't it?
yes.
Sir, the same thing we can do by turntable. So why we are using robots here?
Application. If someone wants a robot for inspection purpose or some special purpose, then in that cases they can use this based upon the industry perspective only. See, if this is the layout they have created, if this is the layout they are using, then in this condition you can remove this robot and you can use a turntable or a turn plate and you can use some other things, so that how you are optimizing the plant, how you are saving the resources, how you are saving the energy consumption, that is what our duty is. Okay, this is how we need to create. If this is the actual layout, then by using the actual layout we need to do the modification. So first this is the layout was done, then with this layout, with this line, production line, how much power it is consumed, how much input it is, I mean how much resource it is consuming, how much throughput is there, so what is the total time, like I need to collect all the statistics. Now once the statistics were done, then I need to do all the modification part, like reducing, what will happen if I reduce the conveyor length, what will happen if I remove this robot and I will use a direct conveyor, or else what will be happen if I use a turntable here, like different scenarios we are going to do in the modification layout, that is called as a what if scenarios. That is what exactly we are doing in the next phase. In the first phase, we are going to create the layout. If it is an actual model, then we are going to create a layout like this. If it is a new layout, then also we need to create a layout like this. With by using the robot, I am getting this much of output. If at all I am not using a robot, instead of a robot, I am using a turn plate, then what is the output I am expecting? So how much power consumption I'm expecting? Like I need to create a separate data sheets, like case 1, case 2. By using, in case 1 I'm using a robot, in case 2 I'm using a turn plate, in case 3 I'm using a direct conveyor. Like I need to create multiple cases and I need to collect multiple results, so that at the end of the day I need to do the analysis part, like what exactly happened if I use this one, how much power consumption, all the statistics will be collected. I need to do analysis part out of 3 cases, which is the best one, I need to finalize it. Once I have finalized the own direct conveyor, then I can use a direct conveyor here instead of using a turn plate as well as a robot. Like we need to do the analysis part in the later phases. Clear?
Yes, sir.
Yes, sir.
Now see here, same process. Now I am connecting this with this. Now this robot is having two inputs and two outputs. Now see what will happen. Okay. If the robot is having one more thing also, like control C, control V. Sorry, what is control C? And control V. I am placing here. So I can connect this also. It is just like a turntable. So based upon your application, you can use n number of operations by using a robot. Simultaneous one, two, and third. Clear? And just like a turntable, you can optimize the things also here. Angle table, time table. In angle table, if you click this angle table, you will be having the relationships. What is the input and what is the output? Input at angle, what exactly the angle it is receiving. At output, how the material is collecting. You can define that angle also. If at all you want to do 260 instead of 260, if at all you want to go for 245, directly you can give that and you can use that also. Here I don't want 108, here I can use 120 degrees. Instead of 50 degrees, I want to use 60, 0, 180. I have done this one. Okay, apply, okay, reset the simulation and run it. Now see, the angles will going to change. 1, 2, 3. Okay, if you reduce the speed, clear?
Yes, sir.
This is how we are going to use a robot in an industry. Basic thing. So we need to add a robot here and we need to give the input connections and we need to give the output connections. If you want in detail, I mean, if at all you want to give additional instructions, then you need to enter into robot characteristics. In that robot characteristics, you need to enter into angles table. In that angles, there will be a lot of angles here. If you give in systematic order, then you will be having systematic. Like instead of conveyor 2, I can give input conveyor 1, output conveyor 2, output conveyor 3. Then there will be having notations like this. And with this, you can clearly identify what exactly the input angle, how the input angle is changing. Like all those things you can clearly visible here. You can modify also. There is a times table also. In the times table, which means so when exactly the robot is picking and when it is placing, how much time it is taking after picking apart, how much time it is taking to reach the station. That is what exactly this timetable is. 6, 0, 6, 4, 5. This is the regular intervals at which the part is collecting default angle. So this you can be seen in the analysis chart. But as of now, it is not that much useful. Once you are doing the final analysis part, at that time it will plays a key role. Why? Because how much time this robot is picking a part and placing here, how much time it will take in the first run, in the second run, third run, like different lanes. So how it will be used? Like you can calculate all the results in this times table. Okay, and there are some other factors like time factor, default angle is like, see, initially this is what exactly default angle is at this station, but part is collecting from this station. So I can change this also. Instead of this one, I can go to 180, apply. Okay, now if I run it, see what happened. Previously the robot is in this direction, now the robot is in this direction. Default angle I can change. With this default angle, what will be happen? So whenever the part comes, there is no need of robot to rotate from this to this direction. So anyhow it is in this direction, so the robot will pick a part from this conveyor 2, and it will deliver to the next stations instantly. That is one of the thing you can change. Blocking angle, capacity of the robot can also be increased. Here the robot is picking only one part. I don't want that one. I can go for 2. See what will happen if I increase the capacity to 2. Clear? At every run, the robot is collecting two parts and it will be delivering to the subsequent station. Like this is also performable. There will be having multiple options, but the basic is this one. So how to connect a robot with the inputs and outputs. Once you are familiar with this one, then we need to enter into internal things like internal angle modification, like default angle modification, capacity modification. There are some more things which will be discussed in the later phase. This is mu conveying direction, which means what is the rotation, how it need to be rotate, whether it need to rotate forward or whether it need to rotate in clockwise, anti-clockwise, which direction it need to. Once the part is given, once the operation was done, then what is the final position, what is the default position. So whether it need to reach to home position, or it should be at 90 degrees, or it should be at 90 degrees left, or it should rotate 180 degrees, like different things. Generally we will be using retrain, which means, so once the application was done, generally it will come to its home position, so that what will be happen, again it will be ready to pick the second part, that is called as a retain. We will be using generally in retain. If you don't want that, then directly you can use different aspects. Okay, you can check all these things when you are working in 3D atmosphere, so that it will be clearly visible what it is in 90 degrees, in clockwise, in anti-clockwise, 180 degrees, forward, lateral. All these things will be clearly visible in 3D representation. Okay, that will be discussed from the Monday onwards. Fine. This is a simple robotic application. Clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, uh, I'm deleting this model. I hope it's clear, right?
Yes, sir.
Fine. Apply or delete. Now there is another thing I want to run. Input, output. Till now we have used only one station, which means, see, here what is happening, if I run the simulation, how many parts are processing at a time in this station?
One. So one.
Only one part. If at all, if there is an industrial application where what will be happen, multiple parts need to enter, or two or more parts need to enter into the machine simultaneously, the work need to process. At that applications, we are going to use parallel stations. If you click parallel stations and place here, there will be having this thing. Okay, there will be having two junctions here, actually four junctions. So see, have a look here. Let me connect these two. Let me delete this one. And here I will be using a conveyor. Now see what will happen. See, what is the capacity of this machine?
4.
Four machines. So which means this machine can process at a time four parts. Once the four was done, see, it will be waiting. We need to give the time. Each and every machine is having 10 seconds. Each and every process is having 10 seconds. So once it was done, it will wait for 40 seconds. Oh, sorry, it is not connected. Now have a look here. First part, second, third part, and fourth part. Here there will be having 10 seconds of processing time. Once it was done, the four parts will be released. This is called as a parallel station. Clear? We can increase.
Yes.
We can increase the number
Yes.
also. See, if at all you want to increase, if at all you want to increase, then double click on it. So there will be x dimension, y dimension, which is 2 into 4. 2 in x direction, 2 in y direction. That is a total 4 parts. If you want to increase, you can click 3 and apply. Now how many parts it will produce? 3 into 2, 6 parts it will produce. Now see, first, second, third, fourth, 5, 6 parts, 6 parts. Like you can increase the capacity also, or else you want to do only 2 parts, then 1 into 2, apply, okay. Now see what will happen. Only two parts will going to produce. First, second. Clear? We will call this as a parallel stations. Generally, some industries will use these parallel missions to operate a same part. Or if there is an application, if there is a rectangular block is there and I want to do chamfer on four sides, then what will be happen? First mission will do on first, second mission will do on second, third mission will do on third, fourth mission will do on fourth part, and the four parts will be released. That also
Excuse me,
happens.
sir.
Yes.
Sir, means it is mandatory for this parallel mission that it will release the products at the same time,
Yes. It
because
will.
suppose the first product came and the second product took 5 to 10 seconds to come to the station. So at that means first product was being in process of 5 minutes, 5 seconds.
Hmm.
So
It will wait.
the-
So the fourth part need to be completed. Then only it will produce the part. Otherwise, it won't produce. It will be waiting. It will be in waiting phase. Now see the first part entered. As you said, first part entered. After 10 seconds, next part entered. After 10 seconds, next part entered. Then these two will be released. Until unless this part, the first part will going to wait until this second part operation was completed. This is how exactly it will happen. If this parallel station is having four missions, I mean four workstations, then what will be happen? First part will come and 10 seconds processing time, 10 seconds processing time. Third one also 10 seconds processing time. Fourth part is also 10 seconds processing time. Once the fourth part processing time was done, then four parts simultaneously released. This is what exactly happened with the parallel stations. That is why some industries will use, some industries will won't use based upon their applications. They will use these parallel stations also. Okay.
okay, sir.
Now I am done with this one. These two are done. Assembly and dismantle sections I will explain you in 3D so that you will be having a clear representation. Next one, robot we have done. Store I will explain you in 3D. Buffer I will explain you in 3D. What are the things? Okay, fine. Now there are few more things. Charts. Today we will discuss about charts. One of the important topic. Let me delete this guy, and here I am using this is the basic model. If I reset and run the simulation, what will happen? It will run like this. Will there be any blockage or will there be any waiting?
No, sir.
So to check that thing,
No, sir.
how we need to do is, so there is this user interface. In this user interface, there is one section called charts. So we need to click the chart and we need to paste it in the frame. So once it was pasted, then for what you are going to check for the missions. So you need to select all the missions by clicking control. First mission, hold the control and press or select all the four missions. Once the selection was done, then drag all those things and drop on this chart. Then it will ask you for a resource. Always select the resource only. Occupancy is not a matter. Occupancy is for buffers. Whenever you are going to use a buffer, then you are going to use this occupancy. Otherwise, generally we are going to use the resource statistics only. It will be showing the working atmosphere of a mission, working conditions of a mission in this resource statistics. So we need to select resource statistics and click OK. Now there is a empty chart that was visible here. Now I can run the simulation. Here, if you're using a chart, then definitely there is an end time that is needed. Either with respect to parts or with respect to time, there should be having an end time. Then only this chart will give you exact value. See here, there is no any end time. If I run the simulation, it will be showing like that only. Always it will be showing like this. If there is an end time, which means if it is having 2 hours, okay, if I, where is this event controller? If you reset it, if you run it, done. 2 hours was done, and this is what exactly the process is. Why the process is completely in green in color?
So because every machine has equal processing time, so there is no waiting or blockage.
Now, in real, this is 10 seconds. I don't want 10. Here I will be using 90 seconds, 1.5 minute. Here I will be using 150 seconds in general. Again, I will be using 120. Again, I will be using 1110. This is the actual line. This is some line in an industry. I want to modify this one. I want to check this mode. Now I am reducing the speed and now what have you observed with this chart?
Sir, blockage at first station.
Why there is a
Blockage at
blockage?
first and waiting at station 2 and 3.
Why there is a blockage at station first mission?
So, so because the mission 2 is taking more time to means process.
Now what? Why there is a waiting phase for station 2 as well as station 3?
So because missions are waiting so that input should come so that they can process.
Okay. Now what will be the solution we need to offer to the industry? See, in industry, this is a bigger problem. Yellow is always. Who is this one? Okay. Always this yellow is a. This is the flow. In industry, yellow is always a negative thing. So they will always try to reduce this yellow phase. Yellow phase is not is like blocking. I hope you know blocking, right? So I have explained you. Can you explain me what exactly a blocking phase is?
So the means inputs are waiting to be processed.
Okay.
Means
Okay. So can we use this? I mean, is it okay if we use this blockage in the plant?
No, sir.
Why? Why no?
So because it reduces the efficiency of the plant.
Okay. So blockage is nothing but work in inventory, work in progress. See, there are a lot of parts that are waiting for this mission, which is no way acceptable for industry, which means either the mission can wait for a part that is acceptable, that can be manageable, that can be altered. See, now these two missions is having a waiting phase. I can increase by different means. Okay, whereas this blockage, I will try to reduce this one. There is a option, there is a possibility to reduce this one. Otherwise, what will be happen? There are a lot of parts that are waiting for this process. So with this, my inventory, VIP inventory, work in progress inventory will going to increase, because of which my rate of production going to fail or decrease. So that this is a major or a major problem for an industry. So now as an engineer, we need to reduce this one. Now how to reduce this? How to reduce this blocking phase in between station and station 1? What are the different
Using
methods?
buffers, sir.
Using buffer. Okay, as of now I don't want to use a buffer. With the conveyor only I need to do this thing. How can I increase this with respect to conveyors?
either we can add one more mission or we can increase the material handling time.
Yes. See, I hope I explained you in yesterday's session. In industry, what will be happen? Increasing the number of machines will always be a not accepting one. Why? Because each and every machine will be cost around some lakhs, maybe some 10 lakhs, 20 lakhs, maybe crores also. So if you ask the industrial person to add another machine, then what will be happening? Definitely they are not going to accept it. Why? Because this is a standard process. With this process, they are getting some 70 percentage of efficiency. Now I will be getting 75 or 80% efficiency if they add one more mission like this. Now because of this, what will be happen? The cost of the input cost, the raw material cost will also be increased. The capital cost will also be increased. Again, it will be a non-interesting thing for industry. So I don't want to invest into on the mission. So the alter thing is to increase the length of the conveyor. Now see, I am deleting this one. Instead of this, if I'm having some resource, at least some space utilization, if at all I'm having some layout, additional layout, then I'll be using where exactly this conveyor. Maybe like this. Okay, so I have planned like this. Now let me check what will happen. What happened? I hope they are connected. Okay, it was connected now. By increasing this one, what happened? At least this machine is not in blocked phase. Now I have at least tried the load. I have tried to remove the load on the first station. Now this can be manageable, this can be altered based upon, as you said, if at all I increase the number of missions or I increase simultaneous process, or I need to do some other thing, then I can reduce this one. Whereas blocking is not at all acceptable, which is somewhat acceptable to the industry. I can showcase this one. So if I increase the length, if I increase the length of the conveyor, then you will be removing the blockage space in your industry. Maybe this is acceptable for the industry persons. This is how we are going to do. Okay, now first
Sure.
process. Yes.
Sir, suppose we are manufacturing a product and we are having four missions, and every missions are means independent, not means not related with the previous one.
Okay.
So suppose there is blockage is means blockage at mission two.
Hmm.
So can we means skip that mission so that it can go to the further mission, and then after completing it, it can come back to the missions.
Then the product layout is completely disturbing, right? See, if at all we need to follow the sequence is disturbing. If the sequence was disturbed, what will be happen? So I have prepared a line or a layout with respect to product or process. If the product was disturbed, if the process also disturbed, then I need to prepare the layout based upon the product, based upon the process. So as you said, the mission 2 is taking much time. So I want to give material to mission 3 instead. Once it was done, I want to get back the material from this state. Okay, which is acceptable. But what will happen? The material movement from 1 to 3, 3 to 2, again 2 to 4, there will be having a lot of clumsy in the process. So because of it, maybe I can rearrange the missions. Just a second, like this. I can drag this one here, I can drag this one, I can maybe interchange the missions, and I can try to do the process. That is also acceptable in digital model. Once the digital model is showing much results, positive results, then I can exhibit it, I can showcase it to the industrial persons. If they are accepting it, then I can relocate the industries, then I can remodify the layout. This is one of the method. Okay,
Yes.
fine. See, this was done. Now there is one more thing. Till now we have discussed about these line layouts only. Now I will be showing you a convergent and divergent models, which is important in industry perspective. This is my model, complete newer model. Here I am connecting. I want to connect it by using the realistic connections. See, this is the layout I have created, and from this so now this is the typical model which I have prepared. If I'll say this as a layout, maybe some raw material, some plant, I don't know. So let me first check these things. Rename M1, this one M2. So if you give names, what will be happen whenever you are checking for a chart, whenever you are using a chart, it will be easy. It won't be getting confused. So what will happen if I use a station, station 1, station 2, station 0, maybe there is a chance of confusion. But here, if you donate it with some names, then you won't be confused with these things. M, M6, M7, M13. Okay, now this process is having these many missions, 13 missions, and there will be having input and an output. Now I want to run this simulation. So I want to run it with respect to not to, so I want to run it for 1 day. Okay, I haven't given any input, I want to run this one, and here I am going to change the processing time. See, for the first mission, this is common, I am giving some 90. 90 seconds of processing time. Okay, same for these three machines. Okay, and this is for 90, whereas the second mission which is having some 60, which is having 60. Again these four missions will be having 120, 120, and this will be having 60, 60. This might be 50 and 50 final process. Okay, now I have defined it. So if I run the simulation, I need to reduce the speed and click OK. If I increase it, if I increase it further, okay, at the end of that, it is what exactly the process is. Now, how to check which machine is having bottleneck, which machine is having waiting phase? How to check that thing? How to check the mission resources?
So we will introduce a new chart and assign it to the
Okay,
missions.
for that I will be using a chart here. I have imported a chart. Next, what is the next method?
We will assign means assign the
Select all
missions
the
to the
machines.
Okay, which option I need to pick?
resource statistic.
Okay, now this is the bar. Let me reduce the speed and see. If I increase it for further, now can you explain me this chart with the process?
Sir, machine 2 and machine 7 are heavily blocked.
Why? See, M1, M2, M3 will be having same processing time, 90 seconds of processing time. And M4 and M5 are both, our missions are both, which will be having same processing time. Now, why it was having a blocking phase? Why only M2 is having a blocking phase? Out of these three is having same processing time, right? If you check this one, 1 minute 30 seconds, 1 minute 30, and it is also having 1 minute 30 seconds.
Sir, because of machine 10, sir.
because of mission 10. And see, mission 10, what is the processing time of mission 10? 1 minute. Mission 11, 1 minute. Now these both missions are having same processing time. Then why? Again, M10 is only blocking, M11 is not blocking.
So because M10 is having two inputs.
M11 is also having two inputs. See, M11 is also having input from conveyor 15 and input from conveyor 16.
No idea, sir.
सर M7 मशीन की वजह से हो रहा है मोस्टली.
M6 processing time is 2 minutes. 2 minutes. 2 minutes. 2 minutes. All the four missions in this same process will be having 2 minutes of time, which means these four missions are having same processing time. Then why only M7 is creating a blocking phase? Why M6, M8, M9 are not even producing any blocking phase?
Because M7 has two entries, two inputs.
M7 has two inputs. Okay.
Yes.
M8 is also having two inputs. See, if I click this one, just a second. See, M8 is also having one input from this one and one input from this one, just like this one. Same, M7 is also having two inputs, M8 is also having two inputs. But why only M7 is showing this much of a blockage? Have you observed any error in this process? Layout error.
Conveyor length problem.
No, not that one. I am saying layout, process problem. Have you identified any process problem here? What exactly happened in M1, M2, M3? Or will
So
this
maybe
it is having
not
same
connect.
process or not? M1, M2, M3 is having the same process with same processing time, right? So after that, what is happened? M1 is connected to M4, M3 is connected to M5. What about this M2? M2 is connected with which mission?
Directly to
Seven.
M7.
Directly to M7. But in between, there is a process, systematic process running on, which means after this first, maybe it's a milling operation. After that, there is a drilling operation. Once the drilling operation was done, then they will be entering into threading section. Maybe this is a threading section. But here, what happened in an, I haven't seen that one. So I have given direct connection between M2 and M7, which means after the milling, directly I have created a thread section without having a drilling here, which means there is a problem in the layout. So now I am resetting it. I am deleting this conveyor. Instead of it, delete. Where is this conveyor? So the original method is, now is it acceptable? These two are connected with this mission. Same,
Yes, sir.
this mission is going to, now see what will happen. Okay, from M1 I have given to M4. This is first process, second process, third process, 4 and 5. 5 different processes it's going to happen. From first process it definitely need to connect to second one. So M1, M2, M3 are first process and the parts from the first process will be connected to second process. See here, M4 and M5 was connected. From M4, M5 the parts will be connected to third process, that's nothing but 6, 7, 8, 9, and from 6, 7, 8, 9 it will be connected to 10 and 11, that is the fourth process and fifth process. Now if I run the simulation, let me open this one, right click and show. If I run it, now what happened? This is the actual problem. Okay, in the previous model I have created layout mistake. Now I have done the correct one. So if I have modified the layout, and the modified layout is having this much of blockings. Now how to eliminate these things? Okay, I will be giving you this as an assignment. How many missions total here? How many missions? 1, 2, 3,
30.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So create a model like this, take a screenshot of it. 13 models. You need to create a 13 models with 5 different process. 1, 2, 3, 4, 5. Convergent, divergent. I hope you know this, which means expanding and reducing the number of missions, which will always create a bottleneck as well as waiting phase in the industry. So if see, each and every process is having individual mission. Instead of 2, if I'm having a 3, same here, instead of 2 it will be having a 4, or instead of 2 it will be having 3, then what will be happen? Maybe it will reduce, these blockings will reduce. But in industry what will happen? This is an important process, or at which where the CNC machine will be used, or costlier mission will be used. Now I can't increase the number of missions here, so that I can add a multiple conveyor, so that even though it will wait time, but it need to do operation on this mission only. Then at that point of time we will be having this much of blocking, blocking as well as waiting. Now if at all I want to modify it, I want to reduce this blocking phase, then what will be the alternative method? Okay, create this simple method, create this simple model, and try to decrease this one. See, I am taking a screenshot. It's taken or not? Okay, now same thing. You also, if you want, you can take a screenshot of this one and create the same model. Try to alter these things, try to reduce the blocking phases. Okay, on M7, M1, M2, M3, wherever the blocking phase will there, try to reduce it and show me tomorrow. Okay, so that on the Monday session, so that I will be having a clear idea whether you are understand, you are grasping this or not. So if you not, if they will be having still problem, then I'll explain you on Monday how to do some modifications. Clear?
Yes, sir.
Not only this model, if the model is in a straight line, then in the straight line we won't be having any problems, any blockage as well as waiting phase. Why? Because the layout is a stationary one, mandate straight line one. In the straight line layout, what will be happen? You won't be seeing any blockage. Even though if you see a blockage, it will be like a 5% or 10% or max of 20%. But when the model is having a convergent as well as divergence, this much of connections, then definitely your plant will be having this much of blockages. This is the running model. If at all I'm saying this as a running model in industry, one layout, one production layout, or one production line. In this I will be having this much of blocking phase. Now by using this plant simulation, you need to increase at least, see here with this thing, at the end of a day I am getting how much parts? I am getting 2150 parts. Try to take a screenshot of this also. Okay, try to take a, so that try to increase this. Instead of 2150, try to increase the number. Maybe even though it is 2200, it is acceptable. Why? Because you have increased 50 parts in the production per a day. That will give some boost to the industry. So if you have enhanced it, if you have completely managed it to get 2250 or 2300 or more than this, see in input how many parts it was produced. It was 2350 parts are produced. Out of 2350, you have only achieved 2150. The rest parts are in this conveyor. In this process, if you try to get some more action, more than this one, so actual one is 2150. If you get more than this one, then it will be a beneficial to the industry. Okay, that is what exactly your task is. Create this model and try to get more than this one, 2150, more than that one. If you prepare a model, maybe it was altered. Why? Because the length of the conveyors, the distance between the missions will be altered. So try to create, no, not with the exact length, according to your own wish, but it should be having 13 missions. It should be having model like this, and with that model, first initially create a draft model. In the draft model, try to check the drain statistics. In that you will be having some figure, like this is the figure, and how much your input is. Now try to alter both. So if basic model, in the basic model you will be having input is 2500 and output you are collecting is 2500. There are 400 parts that are in the progress. Now your task is to increase that one. Your task is to decrease the work in progress inventory, WIP inventory, and you need to maximize the production instead of 2150 or instead of 2000. So you need to achieve, you try to achieve 2110 or 2200 or 2300 more parts from this one. Okay. One more thing you need to understand: don't add extra mission. Missions are mandatory. Missions are the mission figure is fixed here. 13 is the maximum missions you need to use. By using these missions, do your model and create different models. First create a basic model like this, then save this model or take a screenshot of that one and alter that one. Try to do some alterations, try to do some modifications, and try to achieve more number of output. And so take that screenshot also and share those two screenshots to me. So what I have with the initial model and what is the modifications you have done. With the modifications, what have you achieved? That's it. Understood?
Yes, sir.
Yes, sir.
Sir.
Okay. See, while working on that model, so you will be having a clear idea on what are the things you need to perform, what are the things not to perform, what will happen if you alter a length of the conveyor, what will happen if you use a straight conveyor, what will happen if you use some other device in this one to increase the rate of production. That all those things you can check by using this type of models. Clear? Now I am not entering into this model again. We will be discussing in the Monday session. So I am saving this model. Save.
Sir,
Yes.
sir, I think M10 is not connected with conveyor.
Yes. But still, I have given you something. So just check on this one. Okay, good one. So it was not connected. If I connect, definitely there will be some alterations will be there. Okay, that we will be discussing on Monday session. So now we are going to practice some other tools, not this one. Okay, now I am closing this model. Now create new model, 2D in 2D representation. So we have done the basic tools of this one, the basic tools in 2D representation, and there are the rest of the tools that will be discussed in the 3D also. Okay, but not in 2D. 2D it won't be that much. Visually great. So in 2D I'm not considering. Human, that I will explain you in 3D. Yes. User interface I will explain you. This is one of the important thing, easier thing. Input, output, 1, 2, 3, 4. Align horizontal, distribute horizontal. Now I'll be using a conveyor between stations. Now if I run the simulation, reset it. I want to run the simulation for 2 days. Okay. Apply real time, reset the simulation and run it. If I increase the speed, just wait for 2 minutes. It will going to complete. 1 day was done. Yes, my simulation was done. Now how many parts I have produced? How to check that one? By using this process on 2 days, after 2 days, how many parts I have produced? How to check that?
The throughput of drain.
Okay,
We will take the statistics of the last mission.
last mission or drain. So directly I'm going into drain and statistics. So how many parts I have produced? Visible is it? Figure
Yes, sir.
17,275 parts I have produced. This because of default time. Now I am changing it with a different things, 60 and 90. Always the mission timings will be like this. Why? Because each and every mission is having its own processing time. For each and every operation will be having different times. If there is a turning operation is there, or if there is a precise cutting operation is there, or if there is a drilling operation is there where the two or multiple drilling need to done, at the time it will take 5 minutes or 6 minutes of processing time. So processing time will always be like this. Okay, 3 minutes, and here it is taking some 60. Fine. Now let me check the model. Okay, now to check how many parts produced, so I need to enter into drain statistics. 862 parts are prepared. Now each and every time, if at all I want to check the statistics, this is not, I mean, this is the method. So you need to enter into drain or a mission, and you need to go to statistics tab. Statistics tab, here there will be the parts, how many parts entered, how many parts I've entered, as well as exits. So instead of doing that one, there is a one more simpler process, that is user interface. You need to go to user interface. In that, there is a display icon or display tool. So you need to click the display tool and paste it here. Okay, same. Then reset the simulation, drag this mission and drop on the display. See, I'm using the same drag and drop. Click, drag and drop. Same display, drag and drop. One more display, drag and drop. Even for source also I can use source, drag and drop. Now see what will happen. Clear? This is how directly you can check. Instead of going to drain, instead of in properties, instead of checking, this is also correct method. But instead of doing that much thing, so directly you need to use this display icon. You need to click here, you need to drag and you need to drop this one. So that the parts that are visible here, how many parts have processed, how many parts have exited from the source, that will be clearly visible in this one. Okay, so whenever you are creating a model, try to add this also, so that there is no need of doing into statistics, entering into statistics and check the properties at each and every time. If you use this one directly, so whenever a part is entered here, see, reset the simulation, see, whenever a part entered, automatically it will be shown throughput. The next mission is 0, so this part will enter into this mission throughput 1, here throughput is 2. The parts entered into that mission will be visible here. Like you can calculate at the end of the process, even see the process running, maybe after 10 hours I want to stop. At this time, I mean at 11 hours 50 minutes, so what is the throughput for each and every mission, that I can directly calculate by using these display icons. Okay, now there is one more thing here. What is the name of this mission?
Station.
If at all I want to rename it, how can I supposed to do that?
Right click and rename.
Machine. Now what is this label?
So maybe it's the remark, what does the machine do?
Yes,
Or
it is a process, specific process. I will say this as a milling, face milling. Okay, see, it won't be visible if I drag here, but when I come to this section, mission, what exactly it is doing? Face milling. So here, same, rename and mission 2, machine 2, and here mm, chamfer. When you come to this one, so it is denoting mission 2 and the application is chamfer. Okay, same with the station 3. Here I am using machine mission 3, and here drilling. So when I click this one, so mission 3 application is drilling. Last one, if I use this for machine 4, threading. If I click this M4, so there will be mission 4 and it is doing threading application. Like you need to directly describe here. Clear? So that what will be happen whenever you have shared this model to someone, or whenever you want to check what exactly happening this one, so you need to go to this one, so automatically the mission name and its operation that can be directly described here. Clear? Guys, is it clear?
Yes, sir.
Next one is one more thing here. Comment. What is this comment then? See, there is a comment section. See, I'll click this comment and I will paste here text. For that, I need to double click into this one. So here, so I can in the display section, see there is a comment and a display tab. Two tabs will be there. In the display tab, I can write as IMP, important NOT, important note, and I will be using some red color. If at all I want, I can use a red color. And in the comment section, for every 1 hour, mission needs to check for coolant. For every 1 hour, mission needs to check for coolant. Like I have defined something. Okay. Now what is there here? See, if there is a red representation, so that what will be happen when whoever is running the plant or whoever is checking the plant or you are the one who is checking the plant, maybe there is some error or some important information that need to be shared, that information need to be noted, then you need to like this important note or something, mission information, coolant information, like you need to write something. And if you click this one, so there is a note which means in detail there will be having some information. If you click this double click, then it is written here, for every 1 hour mission needs to be checked. If you enable this one, nothing will happen. See, that's it. Information. Okay. And in display section, how it was defined. If at all you want in large, medium, and instead of this red color, yellow color. Clear? Like you can share the information, like you can describe your information clearly in the model itself. Okay. Or else you can add one more thing also. See here, important note in the display section. After 100 parts, which means, see, if I run this one, here there is a zero directly, I mean a representation. So whenever I am running a mission, so the parts will be represented like this. So after 100 parts, which means there is something that is describing. So at 100 point or after 100 points, I need to open this one and check what exactly happened. For every 1 hour or 100 parts, mission needs to check for coolant. Like I have defined some information. So for every 100 parts, I need to check this process, or for every 1 hour, I need to check the process. Like I need to if at all I want to describe something, or if at all I want to mention something, then this is the note section where I need to add something to the model. Clear?
Yes, sir.
Find resources. These are all human. I will explain you human in the 3D. Same information as of now it is needed. User interface, these are the three things in 2D. Mobile units, this will be discussed in 3D. Tools, all these things will be in 2D and 3D only. Fine guys, that's it from today's section in 2D plane. So we are done with maximum contents in the 2D. Okay, from Monday onwards we are going to learn on 3D basics. So how the 3D will be, how to represent, how to convert a 2D model into 3D. So if at all I want to work on 3D directly, so what are the things I need to learn? So how this 2D representation will be converted into 3D? In 3D, what are the different things I need to consider? Like all those aspects will be discussed from Monday onwards. Okay, in 3D modeling. Clear?
Yes, sir.
This is the
Yes.
plant simulation basics. I mean 2D basics completely. So with this session, today's session was done, and this is the just a second, let me close this one model. Okay. So we are done with the 2D content. So this is the last content from 2D. So it was done. Now from Monday onwards, we are going to work with different aspects of 3D. So how the 3D will be, how to start a model from 3D to how to convert a typical layouts in 3D, and how to modify a layout in 3D. All those things we'll be discussing from Monday onwards. Clear?
Yes, sir.
Any doubts so far in 2D?
No, sir.
Don't worry.
No, sir.
Just practice all those things. Like I already given you one assignment to create a model with the 13 missions in divergent and convergent models. Create that models. Not only that one, create some different models, so that when the number of missions are increasing, when the model complexity is increasing, automatically there will be some problems, like the problem which he has raised. I will be having a connector problem. So I need to check each and everything before running the simulation only. Maybe in a run I have missed that one. So because of which my plant is showing continuously showing that much of blockage. So try to do different models in a larger scale, so that you will be having clear idea on better hands-on experience on this 2D platform. Okay. I hope it's clear. If still you are having
Yes,
any
sir.
doubt, kindly
Yes,
note
sir.
it down and ask me on Monday. Okay.
Okay, sir.
Fine, guys.
Okay, sir.
That's it from my side. Have a great
Thank you,
day.
sir.
Enjoy the weekend.
Thank you, sir. Have a good day, sir.
Thank you.